Okay, in the previous video in SLS, there's a video on the proving of Veta's formula or the sum and product of roots using the intercept form. Now I'm going to demonstrate how we can show Veta's formula or the sum and product of roots using the quadratic formula. Okay, so I've pre-written the answers for part 1. And then I will show part 2 later. So let's go through the question or the task. The question is, how are the coefficients of the quadratic equation related to its roots? So we actually want to demonstrate how the general form ax squared plus bx plus c equals to 0 are related to the roots. And right now, the premise is the roots are alpha and beta. Okay, we are telling you whatever the equation, the quadratic equation is, alpha and beta are the roots of the quadratic equation. Roots here simply means the answers to the question. Okay, so you now need to show me that alpha plus beta is actually negative b over a, and alpha times beta is actually c over a. Okay, so this is to show you that the coefficients of the quadratic equation are actually related to the roots. Okay, so we're going to show and demonstrate this, but I'm going to actually use the quadratic formula. So in order to do this, I start by assuming that alpha is greater than beta. This is simply just to assign one value. So if you remember, in the previous section, the quadratic formula is negative b plus minus, right? Plus minus because there are two values, right? So plus minus b squared minus 4ac over 2a. So I have split the plus minus so that I've demonstrated, because since alpha is greater than beta, so the first value is the plus and the second value is the minus. Okay, so alpha will always be greater than beta. So I fixed the values to be this. So now I'm going to demonstrate how do I show that alpha plus beta is actually equals to minus b over a. Okay, so I applied the formula, I applied the formula and I put the values in for alpha and beta. So since whatever the equation is, when I apply the quadratic formula, alpha is this minus b plus b squared minus 4ac over 2a, and beta is minus b squared minus 4ac over 2a. Okay, so what I have done now is I am now writing out the left hand side of the equation, because I'm required to show that alpha plus beta is this. Okay, so I'm going to work towards getting the right hand side. So alpha plus beta, so I've just copied over again. So minus b plus b square root b squared minus 4ac over 2a plus the value for beta. Okay, so these are two different fractions. I've grouped them into the same fraction. Because this is plus, it does not affect the signs of the numerator on the second fraction. So minus b becomes minus 2b, b squared minus 4ac minus b squared minus 4ac will cancel each other. They make 0. So the answer I will get will be minus 2b over 2a, and so my final answer is minus b over a. Okay, so I have actually shown that my right hand side is equals to minus b over a, and so I will demonstrate and say shown here. Okay, now I need to demonstrate how do I get alpha times beta is equals to c over a. So I am actually going to put them together, and I'm going to rewrite this. Okay, let me just make the changes here. Give me a moment, let me erase this. Okay, so for the second expression, I'm required to show alpha times beta. Okay, so let's work on that. Okay, so this is alpha times beta. Okay, so what I'm going to do is I'm just going to put them together, put the expressions together. So this factor, this answer times this answer. Okay, when I put them together, right? What's gonna happen is I am applying the identity. Okay, so I need to remind you, we have learned the identity of the difference of squares. Okay, what is the identity difference of squares? It is this one. Try and use a different color. So the identity of x plus y, x minus y is actually equals to x square minus y square. Okay, so we have learned this identity in the earlier sections of this particular SLS section. This identity is called the difference of squares. Okay, so for this identity, x square is a square number, y square is a square number. This is in the expanded form, and the factorized form is x plus y, x plus y, x minus y. So I want you to notice that this is my x plus y, this is my x, okay, this is my y, and then this is my x, and then this is my minus y. Okay, I can do that. All right. All right. Of course, when you split it up, it will not be just negative b, but negative b over 2a. So you got to be able to visualize that. So I'm going to speed up by just uh, ex using this identity, okay, using the idea of the identity. So I will get minus b squared. So this is my x squared, and then this is my y squared. Okay, because it's inside a square root, when the form is square root form, then I square it, I will eventually not have it the square form at all. So this is my 2a squared. Okay, so the final answer will be b square minus b square minus 4ac. Okay, there is no square because the square root sign and the square will cancel each other, and this one will be 4a squared. Okay, opening up the bracket, I will get b squared minus b squared plus 4ac over 4a squared. Okay, b squared minus b squared will cancel each other. I'm eventually left with 4ac over 4a squared, which will eventually give me c over a. And then this is your right hand side. Okay, so I have also shown the derivation of the proof of beta's formula using the quadratic formula.